This is a walkthrough of the Raspberry Pi Lesson 3. So here I have the code. This is the GPIO.S code. So I'm going to take us through it. So, well, essentially what this lesson does is it's going to allow us to blink the OK LED just like in Lesson 2. However, in this lesson we will be using functions in order to do it. So the first thing we have is, where does it start? It starts right here. So the first thing we have is global get GPIO address. And so what this means is it's allowing it so that other source files, specifically our main.s, which we'll be using, can have access to this label, which will be our function. And so here we have it. Starts get GPIO address, and there's just two lines in it. It's load R0 with the number that we had before. This is the address of the GPIO controller. And then move into the program counter the link register, which is what will always contain the next line. So it will bring us back to here when we call it. So essentially what this is doing is putting us, exiting this function by moving our program counter back to link register, which contained wherever we were when we last branched. So in this code, obviously we haven't branched, but we will branch this label, and so this will return us back where we were before we branched to this function. So the next thing we have is the setGPIO function. So once again, same thing, allows it to be accessed by anything else. And then, so the first thing we do is we're checking to see if the arguments that we're passing into this function are valid. So R0 and R1 are the two arguments. It's going to be the GPIO pin and the function. And so it has to be between 0 and 53, and this has to be between 0 and 7. And so what this does is it compares R0 to 53, and if it is less than 53, so a valid number, it compares R1 to 7. And then if it's higher than that, we just return that's invalid. But if it's not, we will just continue. So this will occur. This is the same as like before. This will occur only if we get an invalid number here. So next we need to push onto the stack the link register, because we are going to be going to branching again right here. So we need to make sure that we can always get back to where we were originally before we started this function, even though we're calling another function within this function. So then we also have to do pretty much the same thing, because we're going to change R0 in this function, as we see right here. We need to make sure we preserve it, so we move it to R2 because we know R2 will not be changed. So the next thing we have is a loop function, and this is going to allow us to determine which block of block of 10 pins we need our pin is in, essentially. So this will allow us to get the location of our pin in the block. So next, what we do is we take R2, and this is sort of a weird workaround type thing. This is actually a multiplication by 3. It's R2 logically shift left 1. So we move it left 1, which will double R2, and then add the doubled value to R2. So R2 times 2 plus R2, which is R2 times 3. Then we shift left R1, which is our pin function, and we logically shift it by the newly multiplied R2. So this will allow us to set the bits. We want to set the bits of our pin number, and there are 3 pins, 3 bits per pin. So we need to do this, and then we're going to store into R1 our completed function value. So what we just got, we're going to store into R1, and then we're going to pop into the program counter whatever's at the top of the stack, and the only thing in the stack that we've put on, the most recent thing we've put on the stack was the link register. So it's going to allow us to pop into the PC, so put us back where we were before. So the final function that we have in here is the set GPIO. So what it does is these two things are actually creating aliases. So what this is pin number will now be bonded to R0, so we can refer to pin number rather than R0 to allow it to be clearer, and then pin value becomes R1. So the two arguments that are passed in. So we're going to compare the pin number to 53. This is the same thing if it's higher than 53. So if we have an invalid pin, just go back to where we were before this, and then same thing as before again. We're going to push the link register onto the stack because we're going to have to branch again. Then we're going to move pin number into R2, then unalias pin number, and then put it back to R2 because for the same reason as before, we need to preserve pin number, and since pin number is in R0, it's going to be changed when this is called. So we put it into R2, get rid of the alias, and re-alias pin number to R2 so that it's able to be used still. And then we're going to get the GPIO address, which is just from before. Same thing, just get the address, put it into R0. And then we're going to R0 now contains the address, so we're going to make an alias, GPIO address equals R0. And then we're going to make another one, pin bank, R3. And now we're going to essentially do logical shifts of pin number by 5, which will allow us to check which grouping of pins the one we are changing is in. This is because the GPIO controller has sets of bytes for turning pins on and off, and the first controls the first set controls the first 32 pins, and the second set controls the remaining 22 pins. So in order to determine which set it is, we have to divide the pin number by 32. And so that's what actually this logical shift left by 5 will just divide it by 32. And then since it has sets of 4 bytes, we have to multiply it by 4. So we logically shift it left by 2, which is a multiplication by 4. And then we add to the GPIO address the pin bank. So this will basically calculate our offset. So we had our GPIO address, which is just where it began, and now we have where our pin's going to be. So we're going to add to the GPIO address, which will be our new pin to pin bank, and then unalias pin bank. So in order to set the pin we need, we have now got our pin bank. So we compute this AND, which is basically going to allow us to, it returns. So then we basically set the bit, make an alias called setBit to R3, move number 1 into setBit, and then logically shift left, set bit by the pin number. Now what this does is creates the binary number we need. So it shifts the number 1 left from the result from our AND, which will allow us to get our binary number to set the bit. And finally, we have this block of code. So what this does is test if equal pin value to 0. So if pin value is 0, then it will store if equal. So if pin value is equal to 0, it will store set bit with the address and the number 40, which is, we know, turns the pin off from before. And if it's not equal, set bit to 28, which turns the pin on, as we determined before. And then we unrequest them, and then we pop the program counter. So we go back to where we pop into the program counter whatever's on the stack, which was the register from before. So we go back to where we were. So the next set of code we have is the main code. So this is what's going to actually make our blinking using the functions. So we initialize, we start, and then we start. So immediately as we start, we just branch to main. And so we have section, we have text. This is a new thing that we can do, which tells us to put this code with the rest of the code. And then we have our main. So this is where it's going to branch with. So we branch to the main, move the stack pointer to this, which is just the default location. Then we make pin number alias to R0, pin function alias to R1. We move into pin number 16, which is the 6. So we want to turn the 16th pin on because we know from before that that's the LED. We want to put 1 in to turn it on, and then we want to branch to set GPIO function, which we saw before in here. Set GPIO function was from here, this whole thing. So we set the function. Here we go. And then we come back after that function completes. We go on and now we have set the GPIO function that we want to use. So now we're going to start a loop, which is going to go all the way down to the end. And we're going to put the I got confused. Right. So this enables the GPIO pin, and then we begin a loop. We set our 0 pin number, pin value. We want to, okay. So pin number and pin function, we want to enable the function. Then we have pin number and pin value. So we move pin number into number 16, or move 16 into pin number. So now we have, can turn the 16th pin off by putting the pin value to 0. And then we branch into our GPIO and do the set GPIO that we had before. And then we unalias. And now we do our delay, same delay that we had before. We decrement, wait until it works. We actually use an alias in this one, so call R0 decrement, move this random number, which is just how big we want our delay. Test if equal, wait, test if equal, wait. Then we do the same thing as this, except put a 1 into the value to turn the LED. Oops, did I say before? Oh, see, look, there's an error in their comments. It says LED to turn on, LED to turn on. But this should actually turn it off, I believe, because setting it to 1 turns it off. So this will turn it off, just like the other one turns it on. Then we do another wait, and then we go back to the loop, and we do it all again. So now our LED is blinking. And that's how this code works for lesson 3.